odds I'm left with only one option. I'm gonna have to science the shit of this.
오늘 우리가 미사일 실험을 한다.
준비!
Alright, so for this lab, you need a couple materials. Safety goggles are a must. You need a rocket. Rocket valve can either be medium, small, or super. You need a rocket base, a bicycle pump, and also make sure you have a piece of paper to record your data.
Alright, make sure you're wearing your safety goggles and don't play around with the rocket.
Alright, so first step in the procedure, make sure that you have all your materials here. Make sure they're all gathered. What you want to do, make sure your rubber head is attached to the rocket. You can see there's a little kind of incision there. Just want to put it on. Second step, you want to take your cap, make sure you record which one it is. You can't see it, but inside there it says medium. Make sure you record which one it is so when you record the data it'll be accurate. You want to pop it on there until it clicks. Take the rocket, put it on, take your pump, make sure the air is coming through the right hole. If it's coming through the top one, then you're all set. So attach it to the valve, lock it in place, make sure everything is set up, no one is nearby, adhere to all safety procedures, and then
Hello, my name is Rajesh Kumar and I am an astrophysicist. Today I will be explaining the calculations of the rocket lab, okay? Very good. First thing you want to do is find the initial velocity. We are going to be using the first trial of the slow rocket, and so our time will be 1/30th of a second because our frames per second is 30. And so what you want to do is using visually check how long it takes in one frame, and that is going to be 0.7 meters, and then you do V is equal to D over T, which is equal to 0.7 meters over 1/30th of a second is equal to 21 meters per second, and that is the initial velocity. Okay, very good. Dude, Rajesh, what are you doing? You know what, I was trying to do physics, you know. Dude, no, your voice is so annoying. Get out. Alright, apologies. Now back to the lab. To find the total time of flight, what you want to do first is find the time it takes to reach its max height, and this is when V final is equal to 0. So using the formula V is equal to V naught plus AT, you can plug in your initial velocity and then your acceleration to get a time of 2.14 seconds in this case. Then you multiply that by 2, which results in 4.28 seconds, which is the total time of flight. Lastly, you want to find the max height or your displacement in the y. You would use the formula D equals 1/2 AT squared plus V naught T. You plug in the variables that you know, such as V naught, and T would be half of the time of the entire flight because you want to figure out when the rocket reaches its highest point. and so using this you get an answer of 22.5 meters, at least in this trial. So if you do these calculations correctly for each category of rocket, you should get a table of data similar to the one that I have here. So that's the end of the rocket lab. Hopefully now you guys have mastered 1D motion and free fall problems. Our group's lab results were fairly precise and they seemed reasonable in relation to what we had observed when we were testing the rockets. For example, whenever we used the high rocket, it would have more airtime and it also went higher, and that was reflected in our data. This lab could be improved with the use of a high-speed camera that would help us get a more accurate initial velocity, and that could help improve the data sets a lot. But other than that, I hope you guys have enjoyed our lab, and thank you for watching.